give the stream a second to settle in here. Just getting started. Alright, looks like we're live. It's been a while, guys. Welcome back, I guess, to the Open Studio design session that I usually do on Fridays. The point of these sessions is really to foster kind of a creative atmosphere through the internet, and I think I might have mentioned this in some previous streams. I'm not sure if you guys have caught it, but I am planning on stopping the live streams after today. I started doing these live streams a year ago on May 1st. So it's actually tomorrow, but a year ago. I've decided that I think it would be best for me to make kind of project update videos so that more people can keep in touch on things that I'm working on. Really this whole live streaming thing got me started back in the hobby of actually doing stuff every week, which is a good thing. It helped kickstart that cycle of doing just creative things, just doing something. I'm just I'm at a stage where I think there's going to be a lot of change in the coming months. There's been a lot of change in the past 2 weeks for me, but going forward, I'll probably be doing project update videos rather than full 2-hour live streams, just so you guys know. That's kind of the whole gist of that, kind of logistics going forward. But it's gonna be an interesting summer and fall. I am moving into a new location, and that location with a larger space, with an open field, with a basement, I can hopefully set up shop and work on larger scale projects. And so one of the first things that I really want to do for that is to create an RC remote controlled plane that can be used as a trainer. And so I think for today's session, we're probably going to focus on that the most, right? I have a whole bunch of other ideas which, we can pursue down the line and, just keep them in the back of my mind. But, one of the very first things that I think would be a great learning experience would be to design from scratch an RC airplane that is very basic, not too advanced, easily manufacturable, and overall just a great option to use as a training aircraft. And you can crash it and not feel bad about it. That's kind of one of the reasons why I was thinking over the past couple of days, months, really, weeks and months, just what exactly I would start doing, once I had that open space. And in addition to setting up the shop that I really, kind of dreamed about, which will take a while. It's going to be a work in progress for quite a long time, because I don't have enough money to throw all into tools all at once, and you don't really need all the tools all at once. But it's like a workshop is something that you kind of build up over time, right? So, and with these big ticket items like, saws, sanders, things like that, it's going to be a long time before everything is really settled. But that said, I am prioritizing, saving up for those expenses. Hopefully they're one-time expenses, so you buy a good tool and you don't have to worry about it for years. Um, that's kind of the goal going forward, is really to set up some infrastructure at the new location. Um, that'll make future builds easier. And we'll get there. It takes time. It takes a lot of experience and know-how to do those things, right? So I was looking into things like CNC machines, which are a little bit out of my price range. They're several thousands of dollars, which, quite frankly, is not a great investment, especially with a channel my size at the moment. But there are ways where you can start building your own custom CNC machines. And CNC machines don't have to necessarily be like, a mill drilling metal. That's a little bit extreme, but like, I mean, in the sense that, like, you have laser cutters, right? You have hot wire foam cutters that are specifically designed for RC airplane applications. Those are some very specific tools that I do want to eventually explore and potentially build into my overall tool set, but it'll take a while before I get to that point. And so I'm just like trying to convey there is a larger kind of plan for just how things are going to develop. But in the beginning, it's just going to be very simple, I think. Just a table saw or scroll saw and a disc sander. Those are a couple $100 each, so probably takes 2 months to save up and get those. You need a workbench, so you need lumber. Actually, lumber is an interesting thing. The price of wood has gone up considerably over the last year, so that might actually make that process a little bit more expensive. And if it's more expensive, it's probably going to take longer to save up and really get working with it. That's assuming that the supply is always there, right? And so right now there is a shortage in a lot of lumber stock. So like a typical 2x4 and things like that. I haven't actually been to a hardware store recently, but that's kind of the kind of rumors going around. Even the housing market has gone crazy because like lumber is such an expensive raw material now. Now that COVID has hit and it's been a year since the lockdown began. So it's really, it'll take time. I'm going to try my best to get what I need and start making things up front, but it will take a while before everything starts to settle into the groove. Get into the groove of things. Definitely will take time to build up, but we are heading in that direction. I'm expecting to close on this new location in 2 weeks. So I'll be moving to a condo in northern central Connecticut, I guess. It'll be close to the international airport here in Connecticut. So I won't give you guys the exact location per se, but it's a good place. It's an open space, a lot of open space, which I really like. And there's a lot of nature reserves around, so you can go out for a walk, go out for a bike ride, things like that. So I think the future is looking bright. It's there's a lot of stuff that I can do once I move into that new location. And it's nice to not have to pay rent, which kind of just goes out of your pocket. If you're paying towards a mortgage, if you're paying towards a home, it's kind of like you encapsulate some of that wealth. You keep some of that wealth, even though it's a house. You can sell off the house later for that amount. So it's like building up your net worth in a way. But yeah, it's interesting. This is my first time really owning a piece of property. It's still kind of a foreign idea to me, but it'll open up a lot of possibilities for the future, which is always welcome. And yeah, sorry if I seem a little bit down today, a little bit somber. There have been some things that I've been dealing with in the past week or two, so I might not be 100% here mentally, or just in terms of wellness, I guess. But we're gonna try our best and see what we come up with. Maybe just doodle a little bit. I don't really have high expectations for in terms of like how much progress we make with this design. Again, I'm gonna go with a pretty lenient approach to this project, designing and building a trainer aircraft. It is technically, it's my second RC project, but really, from sourcing the materials, from buying the materials, to setting up the infrastructure, to building this plane, it's going to be my first kind of RC project in that sense. The really, the very first RC plane that I made was back in college, when I was using student organizations materials to really design and develop an aircraft and build it. And it flew okay. It wasn't the best airplane in the world, but it worked. It's surprisingly it worked. It wasn't the best thing in the world by any stretch of the imagination, but I thought it was pretty neat. You search on my channel HYX-1. It's the Icarus, the RC plane that I made. It's a interesting design. I might revisit that in the future, but for now, the very first kind of project to help me transition into the world of RC from just static gliders that we've been making so far, static airframes. A first transition project, a good one, would be to build a trainer. Right? And so that's really what we're trying to do today. So I'm going to just start doodling and kind of just let my thoughts come as they please, I guess. Really kind of a stream of consciousness type of guy. Don't really have a plan for these live streams. So just the general idea and a direction that we're going to go in. Okay, so I'm gonna start doodling here. Yeah. So this is an app called Concepts. It's a free app, but I think a lot of the tools in here are actually not available unless you kind of purchase a tool set pack or something like that. I think it's like $15 or something, but we're missing a lot of the core features is kind of what I mean. To buy out the full app, I think it's like $80 something, which I don't think we need every single feature, so it doesn't really make sense to do that. But we're gonna start designing a simple RC plane, and we're just gonna start with a doodle here. And this is the nice thing about this app, is that it's infinite canvas, so that means you can scroll in any direction and you'll always have more room to draw on. And so this is really nice if you want to kind of keep on thinking, you're not limited by your canvas size. So that's the nice thing about this. And we're gonna have our nose cone. I like to start with a simple, kind of side profile contour sketch. Two, four. 6, 7, 2, 4, 6, 7. So it ends about here. Okay, it's not. Yeah, that's really annoying. There we go. That's the one thing I do like about Procreate that's not available here in this app, is that you have the option to switch tools by double tapping your stylus, your Apple Pencil in this case. But in Concepts in this app, I think you have to manually select the eraser tool before you can do that. This is like what, 1.5, and it peaks around here. So we have that. All the trainers that I've seen are kind of high wing designs, so I think I might want to try something like that. Or maybe not. Very simple design. Simple, but, you know, kind of clean in execution, I guess. So we're going to try and shape this design. So I have a bad habit of overcomplicating things, and sometimes the simplest solution is probably the best. So, you know, this hopefully is one of the times when I really try and simplify things down. This is a very simple fuselage, I would say. So I'm drawing the side profile. This is kind of the outer mold line. I'm not saying that this line that I'm kind of drawing right now isn't, but it's kind of a secondary feature. It's not really a primary. I guess, like, if you view it from the top, it would be, but I don't know. I just like to keep things, like, simple, I guess. This would be like different contours if you were actually to make this shape. Yeah, we could probably erase all of that, actually. Just a concept, right? So it's just a sketch to get started.
So I think the way that they've done it in the past for these planes is to rubber band the main wing to the fuselage, which I don't know if is the right thing for me. We could even erase this, I guess. This would be a concept where we put the wing in line with the fuselage, so it ends up being a kind of 3D structure where, you know, your wing is, it kind of looks like this, comes out of the fuselage like that, and it's like flat on the top. It's like flush, right? But if you look at a lot of trainers, they're actually interesting in the sense that their wings are just straight up mounted on top like that. It looks very crude, but it's actually a lot simpler to make because there isn't this little notch that you have to cut out, and there aren't these little gaps here that you don't really get to fill. It's not a great transition unless you like custom build a fairing, which for a trainer aircraft, that's a little bit too much effort. So I understand why now that they put it on top, and I think I might do the same, even though it's not the most elegant solution. This is only a trainer, so it's not a high performance aircraft. We don't need to be minimizing aerodynamic drag or anything. Well, it would be nice to have like a nice glide ratio, like a nice L/D lift to drag ratio, which I don't know if you guys are familiar with, but just a quick lesson, I suppose. So you have a cross section of a wing. You have kind of an aerodynamic center here. You pretend that all the weight of the aircraft is going down like that at the aerodynamic center. You also have your lift force pushing your plane up. You have your thrust. And you have your drag, which hopefully should not be all that much, which is why it's shorter. Drawing a shorter arrow here. So the ratio between the length of this lift vector and this drag, right, the ratio between L/D, that's your efficiency, aerodynamic efficiency. Now lift and drag, they are forces. Right, so that would be lift, which is 1/2 rho v squared S CL, where this term is density. Actually, let me just write that to the side here. Rho equals density, V equals velocity of the airstream coming over your wing, and then your S is your planform area. And your CL with a capital L here, this L, capital L sub L, correlates with the lift force here, which is the total coefficient of lift of the wing. There are different CLs, like if you get deep into aircraft design, There's a 2D CL, which would be like CL with a little cursive lowercase l, which looks weird, but we won't really deal with that here. We'll just try and simplify things. And then for drag, there's also CD, capital D down there. So that's total coefficient of drag of the wing. This is just wing. Not sure if you can read that. Wing area. So you have your L, which is that, and D is actually quite similar. It's also that. So this equation, it might look complicated, but it's really quite a simple equation here. You have a coefficient in front, 1/2, which is just 1/2, I guess, but you can actually, let's see here. Let's take L, for example, right? The 1/2 rho v squared term, this is called dynamic pressure. And sometimes during like rocket launches, if you've ever watched a SpaceX launch or NASA launch, they'll call this term max Q, right? Well, actually, during a stage of the flight of the rocket upwards, they'll call it max Q. And Q comes from this term. This is literally just designated Q, 1/2 rho v squared Q. This is dynamic pressure of the air coming around your wing, right? The S term is just surface area. And the CL, that's the kind of magical part. That's the wing. How effective the geometry of the wing is, right? So if you have a wing that produces a lot of lift, you have a high CL. If you have a wing that doesn't produce as much lift, you have a lower CL, right? Wing geom. I'm just going to call it that for now. I should really write this in a separate section, but this is kind of the breakdown, right? So your total lift force is proportional to all of these things. It's, if you have a higher speed, you're going to have more lift. If your air is denser, you're going to have more lift, right? So if you think about it, on a colder day, the air molecules are packed together closer. And so it's actually easier to take off on a colder day in terms of aerodynamic lift, right? So on a colder day, assuming everything else is constant, you would have to take off at a lower speed because your rho is higher, right? So if this term goes up, the v squared has to go down because that's the only thing you can change to keep lift the same, which is, in an airplane, we set lift to equal weight. That's when you kind of take off. There are different terms that get deeper into that, but that's kind of the simple idea here. So you have your S. S is surface area. So if you look from the top, if we have like a trainer aircraft, we have a candy bar wing. It's literally just the width. I guess we could call that length because it's the longest. Width times the length equals rectangle area, right? Area rectangle. And then that's really simple. That's the S term. CL is where it gets a little complicated. You can't really define, like, there are ways to come up with it. That's where like the art of aerodynamics comes in. CL is usually kind kind of determined through tests or simulations, which is why it's not like a straightforward calculation that you can do. But I think, if I remember correctly, CL is proportional also to the angle of your wing, right? So you have CL here, it's going to be proportional to your C little l. There's an equation for this. I don't remember the exact equation, but it's proportional to that, and also you have an angle of attack. So if you have a wing that's like this going through the air, air goes like that, it's not going to produce all that much lift. But if you imagine a wing at an angle, right, the air kind of goes like that, it's going to produce more lift, right? So this is kind of the geometry term, right? So how the wing is oriented in air changes how much lift you get. That's the CL term. And within this term, there is the angle and just the cross section of the airfoil, right? So if an airfoil looks like this, it's probably going to produce more lift than a symmetrical airfoil, which produces technically zero lift, right? So I can't really bad at drawing symmetrical airfoils, but this would have more lift because it's curving more. This is called camber. This curvature. But if you have a symmetric airfoil here, you're not going to produce as much lift. Just so it depends on the cross section as well as the angle. That's the CL term. That's why I call it the geometry term. It's really the aircraft wing itself versus other characteristics like the speed and whatnot. I'm going to erase all of this. So maybe we're not going to be doing this. I'll erase this portion here. I think you guys get the idea of this equation. You just break it down term by term, and you'll be able to understand what it really means. But I think we're going to put the wing on top like this. It's going to be a very simple wing here. I'll make this a little bit thinner. Actually, yeah, I'll just keep the eraser. Change back to eraser, erase this a little bit. Okay, so we're going to attach this wing through rubber bands, which, believe it or not, is actually how they do it in the RC world. I'm going to draw a top view later. And we'll have a tail that's kind of mounted here. So for the boom, I'm thinking maybe a carbon fiber boom, but also that's kind of expensive, so we'll have to compare and contrast. Also, you might not be able to get carbon fiber due to limited supplies and things like that. So we'll have to see if it's available. But if it is, great. We'll use that. So I'll just draw like a kind of circular connotation here for that. And then the actual tail itself probably be built in to the carbon fiber. So I don't know if I should go through it, which actually I think for manufacturing that would be a little bit more difficult. I think what might be easier would be to create some sort of fairing, or I don't want to say fairing because fairings can get really complicated really fast. But we can have it rest on top, right? Just a flat plate. It doesn't have to be fancy because this is only a trainer, but we don't want terrible stall tendencies. So we'll have that. We'll have like a little ledge there, a little transition piece for the vertical stabilizer, which can just be a rectangle. Doesn't have to be fancy. Might bring it all the way back here and give it a little notch to allow for the elevator to move up and down. Sorry about not planning this through. I wrote a little too close there and kind of out of space now, but it's kind of the idea here for the tail empennage. Quite a simple thing, if you ask me, but this will probably be one piece coming down like that, and then this will be another piece, and then we'll just smooth it all over with some sort of paint or decal. And yeah, I mean, that's it. That's pretty much it for the trainer aircraft that I kind of want to build here. We could even taper this. Although taper at these low speeds doesn't really do much. It just looks nice, I guess. You can even curve the wingtip there, or surface there. I'll just kind of erase that. If that's the case, we could even extend this all the way down to make this little notch cut here so that everything just fits together really nicely. And I think that's pretty much it. Again, there's a lot of details for an actual airplane versus like a paper airplane. So you have to plan out things like battery placement, servo placement, things like that, which we'll get into. But I think for an initial concept, this actually looks pretty balanced. This is kind of interesting. Let's see here. Sorry, I'm just checking the chat. Oof. I don't know what I did to the live stream. RIP. Yeah, it looks like the chat is just not available or something. Need a refresh. But anyways, it's a pretty simple design. Oh yeah, landing gear. We do need landing gear. Could actually possibly make this a little bit more. A little bit more wide, or actually deep rather. Yeah, that's looking good. Yeah. And then I think what we want to do is maybe extend this back a little bit. Do want the wing to be covered. Oof. Yeah, not like that, but So this is what I mean by I treat this more like a sculpture rather than an engineering project. I am an engineer by trade, but I think in my heart, I'm really more of an artist. Just put it this way, if money weren't an issue, I would probably be an artist rather than an engineer. So depending on the actual balance of the aircraft, might be different options for what we could do in terms of landing gear. But usually I think the rule of thumb is that the center of gravity should be at about the quarter chord, which means, so like when you have a wing, you have a cross section, for example. I'm just going to draw a random cross section here. So you have a wing like that. You have this measurement right here. Which is called a chord, C. Chord is like the total length, right? So if you have an airfoil that's wild, has some pretty wild cambers, which don't think that this is silly. I mean, these airfoils actually exist. They're just not used on airplane wings. They're used in like jet engines, the turbines, the compressors. They have very strange, very sharp shapes like that. I won't get into those, but the same idea exists. It's from the tip to the tip, right? So that's going to be this distance here. Oops, there we go. That'll be the chord for this particular airfoil. So, it's like a geometry kind of parameter. So what I mean by quarter chord for the center of gravity is that if you divide this in half, I did not draw this to a full unit, but bear with me here. If you divide this in half, you divide this in half again. The first quarter, 1/4 of the total length here, it's not the best diagram here, but this is where you want your CG to be located. I'll just call this CG. So, actually, I think so what I mean by the CG should be located here, I think that might be a mistake. It has been a while since I've taken a class on aerodynamics. That was over 2 years ago at this point in my college degree. Because right now, day to day, I don't work as an aircraft designer. I work as a structures engineer, so I don't really deal with aerodynamics all that much. But the quarter chord, I think, was an approximation of the God, how do you explain this? It's like the aerodynamic center, right? So imagine like all the air coming over your wing. It produces a net force about a point, and that point is here. So I don't know how to explain it other than that. You know, it's kind of just how you treat a wing. So like all the forces around a wing in flight, right? So you have pressure, you have air pushing down here, right? You have a lot of pressure here on the bottom because that's how you produce lift. If you sum up all of those forces, the quarter chord is about which you would say, okay, we have a net lift force or net force this way, just some random force, and then we can break that down into lift, this dotted line here, and drag, right? So that's about the point which we could do that. So I think the rule of thumb for aircraft design is that you want to keep your CG at or forward of the apologize for that. I live next to a highway. Another reason why I'm excited to move out of this place. But another thing that kind of wanted to mention was that you do want to keep your CG at or forward of the quarter chord mark. Oops, just do that. So I think the industry symbol for CG is a circle that's divided into fourths, and I think the opposite quadrants of the circle are shaded. That's kind of the symbol for CG. Kind of just accept it going through engineering undergrad. But yeah, that's the CG symbol. There it is, there or forward, depending on how maneuverable you want your plane to be. If it's very forward, your plane is going to be nose heavy, so no matter how much up you give, it's going to stay level or nose down. So ideally, your plane would be balanced so that you would be able to maneuver up, maneuver down. There are some other measures that I won't get into because, quite frankly, I don't have a solid understanding of it because I don't really use it day to day. But it's called, static margin and neutral point. But if you want to do more research on those, you're definitely welcome to do so. I just won't be covering it here because I'm not entirely familiar with that. If you really wanted to, you could calculate those values and scientifically determine the best location for everything on this plane. But I'm not really about that. I just kind of want to build a plane and fly it. That's kind of why it's a hobby for me. It's like, it's a technical thing, but you still make something in the end. You don't go through all of the paperwork of, this center of gravity is in the right place. This part has to be located here. It has to weigh this amount. The total weight will be this. I'm not very scientific. I don't like to keep track of these things in my projects. It's kind of just a personal preference, right? There are some people that are really into the numbers, and for a hobby, if you're doing that, personally, I don't find much joy out of keeping spreadsheets, but you never know. For documentation purposes, people like to document exactly what they learn and do. I just like to kind of make things and see if they work. So that's kind of the philosophy that I have towards these projects. So we'll have the center of gravity be at or forward of the quarter chord point here, and once that's set in place, we can set like a kind of a how would you say it? I would call this kind of a landing gear piece. This is probably going to be made out of some aluminum frame,
Okay, that's not what I really wanted to do. I'm not sure if I can buy just raw aluminum like that, but on the trainers that I've seen, they're all aluminum. They're all some sort of springy, high uh, elasticity metal that's kind of durable. So we're gonna add some wheels. I don't know if this is in proportion or not. I'm just kind of doodling at this point. We'll figure out the exact geometry and specs later, but right now we just need a rough idea where everything is. I think one mistake that I may have made is the get rid of that notification, is the propeller. I don't think that it's going to be this big. It might be a little smaller. And that's really kind of the art of doing systems design and engineering and planning, which is not really the scope of what I do. But if you size the propeller right, I think you should get a pretty decent performing system. Propulsion is definitely a lot more important in RC. It's non-existent in the projects that I have been doing in the past, but you definitely need to consider it for RC aircraft, because it's literally how you're going to power your airplane. If you don't have power, then it's going to be really hard to fly, unless you live near a seacoast, in which case there's constant, breeze coming in from the ocean and you can just soar through the air like that. But for powered flight, you need a battery, you need a motor, which probably will be mounted here inside the fuselage. I could mount it outside, I suppose, but I think it would be cleaner if it's on the inside. You have your shaft, which couples to the actual propeller through some screw or nut, and then you're gonna have like the motor mount here, and this is like a cutout for the motor itself. So kind of the texture of the motor is interesting. These are brushless motors, so they're going to be quite efficient at what they do if given the proper, working conditions, I guess you could say. But you have that there, and I don't know, maybe like a nose gear or something here. I don't think I've seen a trainer with a tail dragger configuration. So that's where, like, imagine you have a Dorito plane, right, with a tail here. You have two wheels here and a nose gear here. This is called a tricycle landing gear, which I think works the best actually in terms of takeoff. It won't be unstable because these two landing gear, they might have different drag properties. By drag I mean like force, resistance force, so it'll kind of stabilize itself in a way, but if you have the two gears in front and then one gear in back, which does happen for some of these trainer aircraft, you put your tail landing gear on a boom, so that'd be like mounting it here. It actually makes takeoff a little bit more awkward because your plane is at such a high angle of attack.
your plane is sitting like that, and you've probably seen it. It's like the old warbirds that have this kind of geometry, right? Landing gear here, tail wheel in the back. And then when they take off, they have to rotate the tail so that the whole aircraft is level first, right? And then, so your wheel is off the ground like that versus, that has to rotate, and then the whole plane lifts off after that. So I don't think I have to draw that for you guys, but it's kind of the idea here. So I don't really like tail dragger configurations for that reason. They're a little bit cumbersome to work with in terms of takeoff, and sometimes when you transition, your plane might decide to rotate this way or this way depending on how much resistance your landing gear are facing, right? So if you're taking off and this landing gear is stuck and this landing gear is free, it's gonna rotate this way. The whole plane is just gonna tilt that way. It's not a very stable configuration, but they use it because it makes more sense for real life aircraft. For hobby grade aircraft, we can choose however we want things to be. But yeah, in like warbirds in old World War II aircraft, this meant like a very high nose, which is bad for pilot visibility on takeoff as well. But yeah, tricycle makes more sense for me because you're already starting level, and then you tilt up eventually, and you take off like that. And what also is really nice about this is that on landing, it's also nice because if you have like a nose gear that comes here. Oh, sorry about that. A little mistake there. If you have a nose gear that you integrate into the fuselage or mount or whatever, and it comes down here to the very front, and just draw straight. Ground level here, so you actually need a little bit more length for the nose gear if it's a smaller diameter. You could definitely keep it the same size. I just think there would be a clearance issue with the prop in this case. But again, everything here is just concepts, so dimensions don't really matter. I mean, I want to say they don't matter, but you know what I mean? It's like these are all adjustable because I don't have the actual parts in my hand yet, and things might have to be resized or repositioned. You can have them at the same location, I guess. And usually this front one is steerable. I'm not sure if I'll incorporate that mechanism because it does make it a little more complicated, and I just want it to be a simple trainer. I'm gonna erase the middle here. It's not the best wheel hub. Yeah. Probably gonna be a singular rod, metal rod coming down. Again, not really finished on the details in that sense. Things are subject to change as we go through the design process. It's a concept sketch. It doesn't need to be immaculate. But you gotta get the idea. This is kind of the idea that I have for the trainer. It looks weird. It doesn't look like what I would typically design, but this is a powered aircraft. So it's going to be a little different than what I typically build, which is more kind of a aggressive fighter type design. Canard, pretty advanced configurations, pretty weird, unseen. I would characterize it as exotic configurations, but I don't know if that's totally accurate. Canards are pretty normal to the European designs, right? Like the Eurofighter, the Mirage, or not the Mirage, the Rafale. So yeah, I'm gonna try and draw the top view of this. So the way that people have done this in the past is they just kind of use the same marking. Oop, I have it set on eraser. Apologize for that. So that's the front of the wing. This is the back of the wing. This is the nose. Oh shoot. Propeller. Leading edge. Motor mount. Wing. End of fuselage, transition to the boom. That. And then that. And then, okay. That. Okay. Don't need that. So these are some of the major measurements here. I don't know how well I'm going to draw this. This is kind of a little challenging for me, but we're going to try our best here. I'll try and draw a little larger than I normally do. So that's kind of the candy bar wing that we have. This is kind of the motor mount, I want to say. We got to figure out what's the wingspan of this thing. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 2, 4, 6, 6. So that's what we have here. 36. 36 units by 36 plus 6 equals 42. 42-inch wing. That's wild. You might even have to add some taper because that looks like a lot of wing area. So 42 inches, that would be between 3 and 4 feet. 3 feet is 36 inches. For reference, this mat is 24, so it's not quite that length. But if we extend it, oh no, this is 22 inches. I think 42 should be an okay number. Not sure. This is like totally random, I suppose. It's like I'm not doing any like heavy duty calculations here to really determine 6. Yeah, let's just make it a solid 48-inch wing. 48 inches plus 6 on this side. Right, that's 6, 48-inch wing. I'm gonna have to erase this later, but I'm just trying to get the shape down. And sketching this in place. Okay. Okay, looks good. Looks pretty reasonable. The center would be right about. Oh god, it's gonna be somewhere here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 24. This is the dead center of that wing. I just kind of scaled it to this, so I don't know how many units this is. This is 2, 4, 6, 8, 9. This is a 9-inch cord by 48. So 9 by 48, 9 by 48. I'll just keep it to the side here, the numbers. Okay, and so I think we can transfer this. This is where the motor mount is going to be. The front of the motor is right about here. The propeller hub and leading edge of the propeller is right about here. So this is kind of the propeller. I don't really know how wide it's going to be, but we're just going to go with it. Be nice to draw like a line through the center, just for reference, so you have a good idea of where everything is. Looks good. Okay, so that's the propeller, and I'm gonna have a shaft here going to the, I believe is a motor. Motor, I'll just do kind of a little box shape like that. I'm not really sure what kV I want the motor to be, but I just know that it's gonna go somewhere here. Usually there's a sticker on it in the middle, and then the texture is kind of like a radiator, almost like it's ribbed, but anyways, that's kind of a minor detail. And the propeller is going to be mounted I forgot that the motors usually have a little taper like that, but propellers get mounted here. This is a slightly revised sketch of the propeller. I think this is how they actually look. It's a little bit more like this than what I had previously. Also, this is not sized properly. This is like what, 2, 4, 6 radius. 2, 4, 6. That would be right about here if I kept it to scale. So 6 potentially with a little bit more. Not really sure, but I'll just draw it as is for now. We can change it later. And then the nose cone thing is right here. I'm excited to like make the nose cone. It might sound silly, but I'm actually rather excited because I have so many ideas for like how to shape this thing. It's like just oddly satisfying to have it rotate on like a lathe or something, and you know, you just sand everything down to perfection. I live for the little things. But anyways, let's have our fuselage kind of here. This is a trainer, so I do want to make it pretty simple to make, low effort, but still decent quality, you know? quick to make too. I do want it to be relatively fast to manufacture because inevitably I'm going to be crashing one or two or three or more of these prototypes here. So it could be straight, but I think if we are shaping it, then we can also add a little slant to this edge. Yeah. And then for the wing itself, we're probably gonna kind of taper it to a lower chord value at the tip, just because the candy bar wing just looks a little strange to me. Again, I do things based on look, which is not what a real engineer does. Like, I'm not a professional aircraft designer, but I'm just having fun here. Could have it be a third of that chopped off. I think that's a pretty balanced design. And just chop all of that off and then integrate the control surfaces inside the outer mold line of the wing surface. So I'll just lightly erase this. Actually, I can't really lightly erase it, it just erases it completely. But I'll draw in some dotted lines here. I think that looks a little cleaner. Wingtip looks a little crude. You can do a simple fillet operation. Get like Apple TV notification. Oh, that's not good. That's an eraser. All right. I keep it pretty simple here. Just a simple shape like that. Okay, it's a pretty clean wing, I would say. Have the rear fuselage here to deal with, so let's get started here. We already have the dimensions written off to the side, so we don't really need that. I need these small annotations here. Okay, so this is the back end here, and then this is the transition that we need. This is quite a rapid transition. The way I have this right now, it's like 1 inch diameter tube. It might be carbon fiber, it might not be. It could be made out of some sort of wooden dowel. So I'm thinking that probably would be cheaper and more available. You could just go to like a Lowe's or Home Depot or something and grab like a wooden dowel, or like a craft store even. So it's not very restrictive in terms of availability. So I might just do that. Prop, I'm thinking it might, so like I have a pretty non-linear design process, so my brain kind of goes all over the place, so you have to bear with me here. I'm just like drawing extra contours for what the propeller might look like. But yeah, anyways, we have a dowel that's going to kind of come here. Sorry, if you guys are like using the live chat, unfortunately, I think my webpage glitched out here, so I can't really respond to anything, which is a little sad. But yeah, I'll try and. Oh, looks like the side camera is out. Let me check that real quick. Okay. It's on, but I don't think we're using it, so I don't really want to debug that right now. I just want to flesh out the design of this trainer airplane that I'm going to build. Yeah, it looks okay. It doesn't look terrible. I don't think the motor is actually going to be this big. I think it might be a little smaller. This looks oversized for this airplane. Even though I like to have like a little bit of margin in terms of just power available to fly, I think this is a little bit oversized. It might be a lot smaller than that. Which, if it is, then, you know, that's great. But I think I might even have to like extend this out. This is kind of where the artist in me, rather than the engineer, is thinking this will look cleaner. Right. Just giving it a little more reinforcement. I think it actually physically, structurally makes sense too. It's a motor mount, and so you don't want it to be like super thin. You want to have a little bit of reinforcement here. I know there are people that build like foam board planes out there. I think Aerostuff FPV is a channel that I'm subscribed to. I regularly watch his stuff. He builds these very simple square tube motor mount inside, mounted like that, and then the motor's here. And there's nothing wrong with that. It's just I'm trying to custom design a solution here rather than, you know, just simply using a lot of inspiration from other sources, I suppose. But just give it a little bit more margin here. I think that architecture should be pretty good. Okay, I guess I just activated the eraser. So I apologize for that. Yeah, so the propeller has to have enough clearance here. Or we could even bend this piece in. This is really a small detail, but honestly, the way I approach things is everything is important. I try and think a lot about the details because they're really what makes up the design. So it's kind of the idea here is to really make a lean but well ventilated motor mount, because the motor will heat up over time with use in a given flight. So you want to give it some ability to cool off, which I think I did adequately here. Yeah, sorry, this is a little boring. Perhaps not making a lot of progress with the sketch, but I'll try and make things clean so that they're understandable. Yeah, I think that makes sense. And then you have your base plate here. It's kind of mounted. It's probably going to be some type of wood because it's cheap, relatively speaking, compared to carbon fiber. I think in the future, eventually, I will try and approach building a high-performance aircraft, but for now, I think this should be okay. Just a starter trainer plane. That looks okay. That motor might be way oversized in the sketch, but we'll change it later if needed. And then this tail just continues off here. Yeah. So I think that's the end of the boom. I could just continue drawing this and then go there. Kind of ends in like a cropped cylinder sort of deal. So you have a cylinder like that, you cut it at an angle like that, and it becomes kind of oblique like that with a elliptical kind of hole, right? It looks like bamboo in this case, but that's kind of the idea here. It's that tapers. Oh. There we go. Clean it up. I'm going to draw. Oh, God, I'm like kind of out of it. Wow. There we go. Gonna crop this wing off. This little wingtip. I didn't realize that this is like losing a little bit of lift, but I don't think we need all of the rectangle. We can afford to make it look a little nice. Again, this isn't based off of any numerical calculation, but having a little sweep or taper, I don't know, just looks nice. I like it. Okay, and then this will probably be one fuselage piece here. Just kidding, it'll be multiple pieces, and then this middle portion here, this motor might be size small, but this space should be allocated for the battery and whatnot. Oh, Jesus. All right. I'm just going to label it battery. I forgot the sketch is oriented this way, so I should be writing this way. Okay, that's a bummer. Gotta erase this. I mean, I guess you can view it that way, I guess. It doesn't really matter. I'll just write it. Whatever. This is, okay. This is a propeller. How do you spell propeller? 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 I think it's lure. Propeller. And battery. So in a case of a drawing like this, I would actually draw out a dotted line here for the fuselage. Not just shading the battery. It's a hardware piece. And I think the tail is going to be here, right? So it's, where did I say it's going to go? It's like halfway between this and that, and then this goes all the way back here. I don't know how big this should be, and I'm not willing to do the math, so this is 2, 4, 6, 8, 9, this is 18-inch total. This looks about right. And then 2, 4, 5, almost 5. It's like 4.5. And then we'll have like, what, 1 inch off the trailing edge here that is movable. And this is not centered at all. Wow. Two, 4, 6, 8, 9. So it should be all the way here. And cut off a portion of this tail. Okay, that looks decent, I think. Transition from here to here. And then the vertical stabilizer actually going all the way back to the end. But from the top, it just kind of looks like a airfoil. I have to trust that drawing. Yeah, that looks decent. Okay, yeah, that looks good. So I think the only things left are drawing where the ailerons and flaps are, and then placing the servos in a reasonable location. So all the actuators, the mechanical components.
sorry. Yeah, this camera is offline. Might as well turn it off. Apologize for that. I'm back. So flaps and ailerons, those are going to be pretty important for the aircraft in question. I've also included a rudder, because in a trainer you need pretty much all the basic control surfaces in place. And flaps are kind of extra, but they should help with takeoff and low speed performance. So we're going to try and design for that. So the flaps are going to be a little chunky. I'm going to be real with you guys here. It's going to be, I don't know if 3 is a good number, but I think it should be okay. Can taper to 2 at some point. I don't know how I want to split this, to be honest. This is, ailerons can be here. They can go to about a half of the span, half of the half span. So this is a 48-inch wing. This is going to be what? 2, 4, 6, 8, 10. 10-inch inboard. Whoa, okay. I can make everything in line, I suppose. But if we angle it, the rotating axis is going to be slightly swept forward, which might make the mechanical bits a little difficult to achieve. I want to try a new idea. I know this is a trainer and I should be building it in the most conservative way possible, but I do want to try some new ideas for actuation, in that one of the ideas involves just rotating a relatively stiff material and having the servos be inside the fuselage all the way here. But the rotation of the material will allow for the rotation of the control surface. If that doesn't work, I can always probably cut out a little section of the wing and then install servos there. But I really want to try and make this pretty sleek, I guess, be the word. So that could be the inner flaps. Let's see here. That's half, 2.5. 2.5 would be about here.
This looks like a very strange aircraft. Because usually all of these are in line and they're at a slight slant, which I suppose is not a huge deal. I can do that. Actually, that would be cleaner. I don't know why I thought that was going to be a problem, because you can just mount the servo inside the fuselage at an angle to account for that trailing edge slope. So I think this is about the right place where I want it. Have it go all the way in like that. It's 1.5 inch for the aileron surface. Actually, for simplicity's sake, you could probably keep everything the same. So this would be 1.5, right about there. Don't know if I want to split it there. That might be more reasonable, because aileron control, if it's further out, it's more effective, and the flap control, you want your maximum camber to be in an area where your chord is a little larger than, at the tip. So this makes more sense. It's just usually this flap surface is a little bit deeper, but in this case it's just kind of is what it is, I guess. If this is also the case, I should probably cut out a little notch here to allow for a better rotation. It's like a tiny detail, but if it's flush against the fuselage, you can imagine that when it turns along this axis, the material is going to collide with the fuselage on the underside, which is not going to be great. The mechanism is going to jam in that case, which would not be ideal. So for the actual mechanism, so I kind of assume that everything is going to be the same on the other side. So I would usually write symmetrical. Symmetrical as the other side there. Yeah, I just wanted to crop that little corner there. Sorry. I live for the little details, so. Yep. Okay. It looks a little bit more friendly. It doesn't look as technical. I don't know if technical is the right word. This is a little bit technical, but anyways. Minimize this gap, but allow enough for clearance is the plan. And then, yeah, so I should probably draw the internal space here a little bit. This is some sort of wall structure. It kind of ends right here. It could end No, it has to end here, yeah. So my goal is to integrate a servo here, maybe, at an angle, potentially another one here. I haven't actually looked at the details yet, but this is kind of a general sketch. It's gonna have to come out a little like that. I'm not sure what the servos actually look like, because I still have to select which ones to use. But this one will have a direct line to this along the hinge. So basically it's inside the fuselage to a degree, and when you rotate this servo it controls the flaps. Same principle here. I'll have to realign this. So there's going to be a stack of like servos here, and this service line will actually, that's going to be a little tough, isn't it? Yeah, there's going to be some clearance issues because it's line on line. But I don't know. Could go with a different idea here, but I do want to try this idea because I don't think I've seen anyone do it before. This would keep things very, very clean on the wing itself, because normally what you do is you would have to carve out a little area to mount the servo and then have a control horn linked up to the control surface, which, you know, it works very well mechanically, but it just looks a little weird. And, you know, I don't really mind it, but I want to try this new idea where you put it inside the fuselage, have like a rotating long structure that's pretty stiff rotationally, and if you rotate it, it'll control this. So I don't know if that's a good idea because of the torque requirements on the servo. That might be a little higher, which might increase weight, which to me isn't a huge deal, but you know, weight is like a thing that you have to watch out for in these aircraft. So I might do that, I might not. We'll have to see. But another idea is to stack this on top and then have like sort of a line on line. Okay, yeah, I think I keep on saying that, but I think it would be better to show it. So this wire, it's probably going to be some sort of metallic wire. That's the really key element here, because metal is relatively stiff. And you can have like a Z-bend out of plane. So instead of going like this in one plane, at the end here it pops out of the page, and then you can adjust that, you know. You can stack multiple servos on top of each other like that. Servo stack like that. This kind of takes inspiration from the leading edge flap design that I use for the YX-10, the Astra prototype. It's a glider, unpowered glider, but we might control that with another servo stacked on top, something like that. And that looks reasonable. I think this is doable. I don't think it's too difficult. The only requirement is that the material is relatively stiff. I think the nice thing about having like a line, like just if you have a servo like that with an arm that rotates, right? You control it electronically. When you have a control surface like this, and it's connected to the trailing edge here, and there's a hinge, all the force in this linkage is compression or tension, which is really good in a material like steel wire or just piano wire, brass wire, whatever. But I'm not sure about the torsional qualities, right? So if you have like a wire section like this, if you draw like an up arrow on one surface here and an up arrow on the other surface and you twist it, this up arrow might end up being here, and this would still not really see the motion of this because there's so much material in between for such a long distance. So I'll have to test that out. But if torsionally it's sound in terms of structure, then this could save a lot of I wouldn't say a lot of weight. It just saves a lot of hassle, because when you need to maintain things, when you need to replace a servo on a wing, you could just open up the fuselage and do that here, and link up the wire to the new servo. It's a relatively painless process. But if you mount it in the wing, it's going to be a hassle to get it out. It's not going to be as clean, basically. That's what I'm saying. And you know me, I like to make pretty clean designs, so kind of have a layout here for all of that. Flap and flap plus aileron, servo stack. Yeah, probably need a little ledge for that thing. And then the U channel here for the spar. And then I think for the tail, I want to do something similar where I consolidate all the electromechanical parts inside the fuselage, and then have linkages run out to the back to control the actual surfaces. And this isn't for necessarily practicality, it's just nicer to do that. So I know this is a trainer, but I do want to try and keep things relatively clean here, so we can have one servo on one side, one servo on the other side, mounted differently, of course. This one can be controlling. You can bend the wire and then put it along a straw, and then have it come out here. Control the rudder, and then you can have this one control the elevator. So yeah, this is what the yaw servo. This is the not the yaw servo, the rudder servo. Elevator. servo. So I think the layout is pretty much done. Now the question is, will we actually be able to make this, and how are we going to make it? That's a question for another time. We'll have to see about that as we get closer to actually making this. But this is definitely one of the things that I do want to build over the summer once I move into my new location. A decent sized trainer with wheels. Don't know if I want to make that steerable. Could connect it somehow to the rudder control surface, but not sure. This is kind of the basic idea of the plane here in a nutshell. Flap aileron servo stack, elevator servo, rudder servo mounted differently, and I think all of those together will form a very nice, very clean package, so there's no electronics on the exterior exposed at all. It's just some linkages that are moving around here. So yeah, that's, I don't know, that's kind of all I have planned out for today. I keep on doodling, but honestly this stuff is endless. Like, you could spend hours on hours doing this stuff. Thought of another idea where I could increase the flap here, the flap cord, and then, because then they're on different lines, so to speak, and then you can kind of separate the stack a little bit so it'd be more clear, so it's not exactly line on line. But we'll have to see. I think a lot of the design of these things is in the moment. Like, once you have the materials in your hand, then you can start to really make things happen. So we'll have to wait and see until, I have the materials, and then everything's available. And then I can start making this. And hopefully by then I'll have like a routine set where I make update videos. Again, if you're new around here, if you're just joining, or if you joined after I kind of gave a summary of the logistics, I plan on not doing these live streams after this week for the near future, for at least a month or two, because I am in the process of moving to a new place, new location. But I will make update videos. I will try my best to make update videos to keep you guys updated on the progress of various projects that I'm working on. I should probably label this. That's the flap here. Oh. Flap, inboard flap. This is the aileron. And elevator. Yeah, sorry, I just got distracted there. But yeah, hopefully the plan is in these in-between weeks when I'm transitioning, whatever progress I make on any projects, I'll make like a brief update video or something like that. Similar to how Simple Plane, not Simple Planes, like the Lego. Oh God, there's a channel out there that focuses on making airplanes out of Lego and makes like update videos for each project every now and then. So I think I want to try and do that. Makes more sense, reaches more people in terms of updates, and I'll try and keep it like a semi-weekly or monthly basis update, but hopefully that updates more people, because I know not everyone watches these streams to keep in touch all the time. So yeah, this is going to be the last stream for a while. I've completed basically a year of
live streaming every single week. So I think, it's been very nice doing so. Hopefully I can do that in the future as well. If people are interested, definitely drop a comment or leave a chat. But I think the path going forward more likely is going to be update videos, and I have to get in the habit of editing, and I think that'll be good to develop kind of the production side skill sets that I really need to grow this channel. That should be a exciting new change, I guess. Sorry. Yeah, it's a little bit sad, ending these things, but I think it'll help with the transition in the meantime. And I'll still be in touch. I'll just be through actual videos, and you guys have to leave comments rather than a live format. But in the future, when I'm working on these projects over the weekend or whatever, I might just do like an ad hoc live stream or whatever to document some progress, and if not, just make like a video. I have to do a better job at documenting everything. That's kind of like why I did these live streams in the first place. Part of it is documentation. I can look back and see exactly what I did. But yeah, this is kind of the concept that I have right now for this trainer airplane. It's even in the name right there in the corner, Y13A _ trainer. So it's looking pretty good. I'm excited to see where this project takes me. Excited to see how it actually turns out, that is. But yeah. It's I think that's pretty much it for today. Feel free to click off if you want. I'll hang out for a little longer. I think the chat is not really working, so if you are sending in chats, I apologize. I'm not able to see. I can't really see the live chat, but if you have any questions, feel free to reach out to me on Instagram. I think the description of this stream has all my socials if you want to reach out and talk or do anything there. Open book, open to suggestions, open to talking with people, exchanging ideas. That's always how good ideas come about, is through collaboration and other people. So that's pretty much it. We hit the 2-hour mark. I guess I will talk to you guys in the next update video. This is Y13A signing out. It's been a full year of live streaming. Sorry for the blackout camera box right there. Usually it works, but we're doing a top-down, mostly video or stream today, so it doesn't really matter, I guess. But yeah, it's been real. I might do live streams in the future. I might not, but I'll definitely try and produce more edited content, not live ad hoc, and provide you guys with updates, short updates, so more people can stay in touch too. All right, that's pretty much all I got for today, and thanks for watching, and I'll talk to you guys later. This is the awkward part of the live stream where I just have to chill a little bit so that all of the stream gets through, uploaded, and then I end things. Sometimes it cuts my dialogue off, so I don't know. Alright, talk to you guys later. Take care, stay safe, get the vaccine. Life's gone back to normal, almost. Hopefully by the end of summer. Yeah.